Lesson 3.1, Math 020 Pre-Algebra, Introduction to Integers. In this lesson, we will be going over the following objectives. A, represent real-life situation with integers. B, graph integers on a number line. C, compare integers. D, find the absolute value of a number. And E, find the opposite of a number. We are going to start with the placing numbers on the number line. Up until this point, all the numbers that we have been talking about were positive whole numbers. In this unit 3, in chapter 3, when we talk about integers, we will be talking about positive and negative numbers. So if you imagine that all your numbers represented on just one endless number line, with 0 being placed in the middle, all the positive numbers to the right of the 0 and all the negative numbers to the left of the 0. That will give you a pretty good idea what integers are. 0 is the center, and it is like a placeholder, and then you have the positive and negative values falling left and right of it. When we compare integers, or when we compare numbers, it is easy to tell that 1, for example, is less than 3, or 10 is less than 25. The numbers, the positive numbers are very intuitive to us. It is not so easy to compare the negative numbers. And here we're going to go with the rule that whichever number is closer to the 0, which is if you were to imagine them on the number line, and if you compare two numbers, let's say you compare -3 and -1, okay? Whichever number is closer to the 0 is going to be the bigger number. So even though -1, seemingly the 1 should be less than 3, but because they're negative, their comparison is going to be in reverse. It's quite logical because the general rule is whichever number is on the right is going to be larger. So, and you see that with your positive numbers. So if I compare 1 and a 3, you already know that 3 is greater than 1. Because you've seen that before. You know how that works. But because we are working with the negative numbers, it's not as intuitive. But again, that rule is still the same. -1 is on the right of the -3, so it's going to be bigger. It's going to be the bigger number. Okay. All right. So the first thing that we're going to do is we're going to compare the numbers and make sure that you have your number line handy when you do that. So all we need to do is to circle the larger number, looking at 8 and 10, looking at -14, -3. So +14 and a -3. So +14 is going to be on the right side of a 0, and the -3 is going to be on the left side. So 14 is going to be greater than -3. And then two negative numbers, -8 and -4. -4 is going to be closer to 0, so that's going to be the larger number. So, okay. Representing integers in a real life, you are going to try to imagine the situation and then place them either on the number line or make sure that it makes sense to you. So write an integer that represents each numerical value, meaning is it going to be positive or negative? A submarine dove to a depth of 340 feet below a sea level. Usually the sea level, that we consider that as 0. So if we are talking about below sea level, that means -340. So on the scale, and our number line, which would be vertical. So you have a 0. Positive numbers will go up, 1, 2, 3. Negative numbers will go below, -1, -2, and -3, and so forth. Okay. So part B, playing Wheel of Fortune, Sally won 3,800. So the money is coming in to her, so that is just a positive number, 3,800. In a card game, Jack lost 45. So that means that money coming out of his pocket. So the losses usually represented are represented by negative numbers. So that's going to be a -45. And then Jim's golf score is 5 over par. So in golf, when you play a course of 18 holes, the typical score would be 72. So that is kind of like your baseline. So if you are scoring 72, you are on par. That means you're at a 0. So when you score a 5 over par, that would be +5, and we don't really need to do anything special here. It's a +5, positive number. Okay. All right. So the last two concepts, so far we've covered representing numbers on the number line. We have represented numbers in real life, and we compared numbers, integers. So the last two concepts that we will be talking about are absolute value and opposite of the number. So first, the formal definition of the absolute value. The absolute value of a number is its distance from 0 on the number line to that number. So that means the absolute, and then we, so this is the verbal description, distance from 0 on the number line. And then the algebraic expression is the absolute value of a number n is written as n with the vertical brackets around it. So that's how we denote the absolute value. So what we do know is the absolute value is positive for all numbers. So algebraically, we represent that greater than or equal to 0. In words, we translate that is positive, because it represents the distance between the number and a 0. So that means that distance is always positive. Okay. So here is an example where you have two numbers. You have 5 and you have -5. So you have number 5 and you have number -5. If you were to talk about how far they are from the 0, well, the +5 is 5 units from the 0, starting from the 0, going to the right. The -5 is the same 5 units from the 0, but we start at the 0 and go to the left. Because we're talking the absolute value is the distance in terms of how far these two numbers away from the 0, they're both 5 units away from the 0. So that's how the positive value works. Okay. How the absolute value works. So in example 3, we are asked to find the absolute value of the numbers. So we have number 13. So imagine 13, part A, number 13. Imagine 13 being on the number line. It is exactly 13 units from the 0. So the absolute value of 13 is 13. So -3, here's my 0, -1, -2, -3. So -3 would be 3 units away. 3 units away from the 0. So the absolute value of -3 is 3. It's how far it is from the 0. Okay. So part C is a little bit tricky. What we have is we have the double negative here, but so first we're going to evaluate the absolute value of negative 11, and then we will apply the second negative sign to it. So in terms of absolute value of negative 11, it is 11 units away from the zero. So absolute value of negative 11 is 11. And then I have to make sure that I do not lose this extra negative sign. So the answer to part C is, in fact, not 11, but a negative 11 because we had the negative sign in front of the absolute value. All right. We use the absolute value to evaluate expressions. So that's what we're going to do in example number 4. When we evaluate with the absolute value, please treat the absolute value brackets as your grouping symbols. So if we go back to our order of operations and we remember our gems, G being grouping symbol, and we talked about that there could be parentheses, square brackets, or absolute value brackets. So then we have exponents, and we have multiplication or division. M stands for multiplication or division, and S would stand for subtraction or addition. All right, so keep in mind our order of operations. Let's take a look at part A to evaluate. So all we have is our grouping symbols denoted by the absolute value brackets. So look inside your absolute value brackets, and you need to take 8 from 15. So 15 minus 8 is 7. It's still in the absolute value brackets. So now, before I drop them, I need to double check and ask myself, how many units away is 7 from 0? And the answer is 7 units away. So the absolute value is 7. Right? So let's move on to part B. Here we have, we need to take absolute value of negative 7 and add to that absolute value of 10. So absolute value of negative 7. Again, ask yourself a question. How far away is this number from 0? And a negative 7 is 7 units away from 0. So the absolute value of negative 7 is 7. How far away is 10 from 0? Exactly 10 units away. So the absolute value of 10 is a 10. And now that I've dropped my absolute value, I've evaluated my absolute values, I have 7 plus 10, which is 17. In part C, we have absolute value of negative 9. We have to find that one first. Then we have to find the absolute value of negative 8. And then we will subtract the absolute value of negative 8 from absolute value of negative 9. So let's do one thing at a time. Negative 9 is 9 units away from 0. So absolute value of negative 9 is 9. Negative 8 is 8 units away from 0. So the absolute value of negative 8 is 8. I've evaluated my two absolute values, and I need to bring down the subtraction, the operational symbol. And now I'm looking at 9 minus 8, and I know that is 1. The last concept that we are going over in this lesson is the opposite values. So we talked about the absolute value, which means the distance away from the 0. The opposite values, opposite numbers, are the same numbers with different signs. So opposite numbers are same numbers with different signs. For example, 5 and -5. So you have, in terms of numerical value, you have 5 and 5, but one is positive and one is negative. Okay? Another example could be 12 and -12. Again, the numerical part of the number is the same, but one is a positive, one is a negative. So those are the opposite numbers. Okay. The opposite notation is you have the number of n and -n. So when you put the negative in front of the a number, it could mean a negative number, could mean subtraction, but it also is an means opposite notation. Okay. In order to find the opposite, you will just look at the, you keep the value of the number and you switch the sign of that number. So if you're looking at the negative number, the opposite of it is going to be the same number with a positive sign. And if it's a positive number, it's going to be the same number with a negative sign. So for part A, here in example 5, the opposite of -12 is 12. The opposite of 37 is -37. And the opposite of 0 is a 0. 0 does not have the opposite is because 0 is a neutral number. As we saw it in our number line, 0 is in the center and it's neither positive nor negative. It's neutral. And that is all for today. I will see you at the next lesson.